14 billion barrels of oil sit trapped beneath Alaska's North Slope. Enough crude to power every car, truck, and plane in America for 2 years straight. The oil is there. The drilling rights are approved. But you cannot get to it. 800 miles of steel cut through the most brutal landscape on the continent, and that steel is failing. The Trans-Alaska Pipeline System, the artery that has carried Arctic crude to American refineries since 1977, is collapsing. Not slowly, not quietly, catastrophically. Throughput has dropped by 3/4 in 3 decades. Permafrost, that once anchored the pipeline's supports, is thawing into unstable mush. Critical pumping stations have been decommissioned and dismantled. The pipeline was designed to last 25 years. It has been operating for 50. And now, the largest accessible oil reserve in North America is becoming inaccessible, not because we ran out of oil, but because the machine built to extract it is dying faster than anyone can fix it. When construction began in 1974, petroleum engineers called the Trans-Alaska Pipeline System impossible. 800 miles of welded steel had to run from Prudhoe Bay on the Arctic Ocean to the port of Valdez on Alaska's southern coast. 4 feet in diameter, elevated on vertical support members for more than half its length to protect the permafrost beneath. Built to carry 2 million barrels of crude oil every single day across mountain ranges, earthquake zones, and temperatures that drop to 60 degrees below zero. The terrain was too unstable, the weather too extreme, the distance too vast. By the time the first oil flowed south in June 1977, the project had cost $8 billion in 1970s money, $28 billion in today's terms, employed 70,000 workers at peak, and required engineering solutions that had never been attempted at this scale. Earthquake flex joints, thermosiphons, welds that had to hold at 60 below zero. Every piece of it was invented on the job. It worked. For decades, it worked flawlessly. At peak operation in 1988, throughput hit 2.1 million barrels per day, supplying nearly 15% of all domestic oil production in the United States. That was 37 years ago. Today, throughput has collapsed to under 500,000 barrels per day. Pumping stations have been shut down and stripped for parts. Permafrost that engineers spent billions protecting is thawing, and the pipeline, designed to operate for 25 years, is now 25 years past its expected decommission date with no replacement in sight. On March 12, 1968, an exploration crew from Atlantic Richfield Company and Humble Oil struck oil on Alaska's North Slope, 9 miles southeast of Prudhoe Bay. The Discovery Well, Prudhoe Bay State No. 1, punched through 9,000 feet of frozen tundra and hit a reservoir that would rewrite American energy history. Geologists estimated the field held between 9 and 13 billion barrels of recoverable crude. At the time, it was the largest oil discovery ever made in North America. It dwarfed anything found in Texas. It dwarfed anything found offshore. Alaska, which had been a state for less than a decade, suddenly controlled a resource that could reshape the nation's dependence on foreign oil. The timing mattered. By 1968, American oil production was peaking. Domestic wells were beginning their long decline. The Arab oil embargo was 5 years away, but the writing was already on the wall. America needed new sources. What they found at Prudhoe Bay was not just big. It was accessible, onshore, and located on land where drilling rights could be secured without the political complexity of the Middle East. Within months, oil companies flooded Alaska's North Slope with lease bids. The state of Alaska auctioned drilling rights in September 1969 and collected $900 million in a single day, the largest mineral lease sale in American history at that time. But knowing where the oil is and getting permission to drill it are 2 different battles. Environmental groups fought the pipeline in federal court for 3 years. The Arab oil embargo of 1973 changed everything. Congress overrode the court injunctions. President Nixon signed the Trans-Alaska Pipeline Authorization Act in November 1973, and construction began 5 months later. Without the embargo, the pipeline might still be tied up in litigation 50 years later. But here was the problem. The reserve sits on the edge of the Arctic Ocean, more than 800 miles from the nearest ice-free port, crude trapped beneath permafrost. The question was how to get it out. The engineers who designed the Trans-Alaska Pipeline system faced a problem no one had solved before: how to move hot oil through frozen ground without destroying either. Crude coming out of Prudhoe Bay wells reaches temperatures near 160 degrees Fahrenheit. Pump that through a buried steel pipe across Alaska's permafrost, and the heat radiates into the ground, melting the ice that keeps the soil stable. Permafrost collapses. Ground shifts. Steel buckles and breaks. Burying the line was not an option. So petroleum engineers made a decision that would define the project's entire architecture. More than half of the 800 miles would be elevated on vertical support members, steel columns driven deep into the permafrost and topped with thermosiphons, passive refrigeration devices filled with ammonia that keep the ground beneath them frozen year-round. 420 of these supports were spaced along the route, each one engineered to hold the pipeline steady while allowing it to flex horizontally during earthquakes. 3 major fault lines cross Alaska. Engineers installed zigzag sections and flex joints, mechanisms that let the steel bend up to 20 feet in either direction without rupturing. Construction began in April 1974. 70,000 workers moved to Alaska. Welders worked in temperatures that hit 60 below zero. At that temperature, steel shatters like glass if you drop it. Exposed skin freezes in under a minute. Men lost fingers to frostbite. 2 workers died when a section of pipe they were welding shifted and crushed them against a support column. Standard welding techniques failed because the metal cooled too fast for proper fusion. Every weld on the pipeline had to be X-rayed to verify structural integrity. Half of them failed the first inspection and had to be redone. Sections had to be cut out and re-welded in place. Winter work slowed to a crawl. Entire crews walked off the job over safety violations. By the end of 1975, the project was a year behind schedule and $2 billion over budget. Engineers quietly told company executives the timeline was impossible. They built it anyway. 3 years, $8 billion, 21,000 sections of pipe, each one welded in place by hand. When the first barrel of crude reached Valdez on July 28, 1977, the Trans-Alaska Pipeline System was the most expensive private construction project ever completed. Engineers had also predicted a 25-year operational lifespan, putting replacement due in 2002. That deadline came and went. 23 years ago. And the pipeline is still running. Barely. The crisis destroying the Trans-Alaska Pipeline System is not one failure. It is 3 failures happening simultaneously, each one accelerating the others. First, throughput collapse. The pipeline carried 2.1 million barrels of crude oil per day in 1988. That number had fallen below 500,000 by 2023. Production from Prudhoe Bay and neighboring fields has been declining for decades as reservoirs deplete and oil companies shift investment to cheaper, easier sources in Texas and North Dakota. Fewer barrels moving through the line means the oil travels slower. Slower flow means the crude cools as it moves south. Cooler oil thickens. Wax begins to form along the pipe walls. Engineers call this the throughput death spiral, a technical trap where declining production makes the pipeline harder to operate, which discourages further investment, which drives production even lower. Second, permafrost thaw. The ground beneath those 420 vertical support members is no longer frozen year-round. Temperatures across Alaska's North Slope have risen 3 degrees Fahrenheit since the pipeline was built. Thermosiphons that once kept the soil stable are losing the battle against warming air and ground temperatures. Structural inspections in 2023 identified dangerous shifts in multiple support columns, with some leaning several degrees off vertical as the permafrost beneath them softens and refreezes in unpredictable cycles. Third, age. Steel fatigues after 50 years. Welds crack. Corrosion spreads. Originally, 12 pumping stations were built to push oil south. 4 have been permanently shut down and stripped for parts. The remaining 8 are running equipment that was considered cutting-edge in 1977 and is now obsolete, with replacement components no longer manufactured. You cannot fix this with routine maintenance. Here is the part no one wants to say out loud. Fixing one piece does not stop the other 2 from getting worse. 300,000 barrels per day. That is the minimum flow rate required to keep the Trans-Alaska pipeline system operational. Below that threshold, physics turns against you. Crude oil is not a simple liquid. It contains paraffin wax molecules that stay dissolved when the oil is hot and moving fast. When throughput drops and the oil slows down, it cools. Below about 90 degrees Fahrenheit, wax begins to crystallize and stick to the pipe walls. Flow engineers call this wax deposition, and it creates a feedback loop that can shut down a pipeline permanently. Buildup narrows the pipe's diameter, which slows the flow further, which causes more wax to form, which narrows the diameter even more. At some point, the only way to clear the blockage is to shut down the entire line, heat it from the outside, and physically scrape the walls clean. That operation, across 800 miles of Arctic terrain, would cost hundreds of millions of dollars and take months. Worse, if throughput falls low enough in winter, the oil can freeze solid. Not everywhere at once, just in the sections where the pipe runs through the coldest zones or where wax has already begun to narrow the internal diameter. Once a section freezes, the line is blocked. Thawing it without rupturing the steel requires controlled heating over weeks. Operators at Alyeska Pipeline Service Company, the consortium that runs the system, will not say this in public, but admit it in private engineering assessments. Current flow rates are hovering just above the 300,000 barrel threshold. One major field shutdown, one extended maintenance closure, one unplanned disruption, and the system crosses into the danger zone. No plan exists for what happens after that. What engineers will not say in board meetings but admit over beers: if throughput crosses below 300,000 barrels per day in winter, the line could freeze solid in under 72 hours. At that point, the only way to restart flow is a controlled shutdown, external heating, and physical scraping of 800 miles of pipe. Cost estimate, $600 million minimum. Timeline, 4 to 6 months. And that assumes the steel does not rupture when you try to thaw it. The permafrost beneath the Trans-Alaska pipeline is no longer behaving like permafrost. Transitioning into something unstable, something engineers never designed for. Frozen ground along the route stayed at temperatures well below 32 degrees Fahrenheit year-round when the pipeline was built in the 1970s. That stability was the foundation of the entire elevated system. Vertical support members, 420 of them, were driven into permafrost assumed to be permanent, with thermosiphons installed on top to maintain the freeze. But Alaska's North Slope has warmed 3 degrees Fahrenheit since then. 3 degrees does not sound catastrophic until you understand what it does to ice-rich soil. Permafrost does not melt uniformly, softens in layers, refreezes in irregular patterns, and shifts as ground ice turns to water, and then back to ice in seasonal cycles that grow less predictable every year. Differential settlement is the result, where some sections of ground drop while others stay firm, creating uneven stresses on the steel columns anchoring the pipeline. In 2023, structural engineers conducting routine inspections documented what they had been quietly warning about for years. Multiple vertical support members were leaning measurably off vertical. Some had tilted 3 to 5 degrees, enough that you can see it from a helicopter without instruments. Others showed rotational movement at their bases, the permafrost plug that anchored them now rotating like a loose tooth in a socket. Engineers know what comes next. The column tips past 10 degrees. The pipeline it is holding flexes beyond design limits. Steel welds crack. And if one support fails catastrophically, the adjacent sections take the load until they fail too. Cascade. Failure across a quarter-mile section would dump 200,000 gallons of crude onto tundra before anyone could shut the valves. Thermosiphons, designed to remove heat from the ground, cannot compensate when ambient air temperatures rise faster than the devices can extract warmth. Reports were filed. Conclusion unavoidable. Ground is failing. And when the supports fail, the pipeline comes down with them. Replacing the Trans-Alaska pipeline system would cost a minimum of $8 billion. That estimate comes from energy infrastructure analysts who studied what a modern rebuild would require: new pipe steel, upgraded pumping stations, seismic retrofits to meet current earthquake codes, environmental impact studies that would take years, and permitting battles that could stretch longer than the construction itself. Spending that sum to move oil that is already declining in volume and profitability makes no financial sense. Oil companies are not lining up to write that check. BP sold its Alaska assets in 2020. ConocoPhillips reduced its North Slope workforce by 40% between 2014 and 2022. ExxonMobil has quietly shifted billions in capital expenditure away from Arctic projects and into shale plays in Texas, where drilling costs are lower and production ramps faster. Energy economists have a term for this situation: stranded assets. Infrastructure built for an era of growth that now faces permanent decline. Designed to move 2 million barrels a day, the system now operates at a quarter of that capacity. No rational investor replaces an 800-mile pipeline to serve shrinking demand, especially when the reserves it accesses are expensive to extract, located in one of the harshest environments on Earth, and competing against cheaper crude from the Permian Basin that can reach refineries by truck if pipelines fail. And here is the comparison no one in Alaska wants to hear. The Permian Basin in Texas holds 46 billion barrels of proven reserves, more than 3 times Alaska's total, and producers there can drill a new well for $8 million. Drilling the same well on the North Slope costs $30 million. The financial case for saving the Trans-Alaska pipeline system does not exist. Which raises the next question. What happens to 14 billion barrels of oil still sitting beneath Alaska's North Slope when the only way to move it south stops working? ConocoPhillips announced an $8 billion investment in the Willow project in March 2023, the largest private sector commitment to Arctic oil extraction in decades. The plan calls for drilling up to 180,000 barrels per day from a field 30 miles southwest of Prudhoe Bay, with production scheduled to begin in 2025. On paper, the math works. Willow's output could replace a meaningful fraction of the North Slope's declining production and keep total throughput above the Trans-Alaska Pipeline's critical minimum flow threshold for another decade, maybe 2. The infrastructure would be new. The wells would be modern horizontal designs far more efficient than the aging vertical shafts drilled in the 1970s. For pipeline operators watching flow rates drop year after year, Willow looked like a lifeline. Environmental groups saw it differently. The Biden administration's approval of the project triggered immediate lawsuits from the Sierra Club, Earth Justice, and multiple Alaska Native communities who argued the environmental impact review underestimated carbon emissions, and ignored risks to caribou migration routes. Protests erupted. Petitions gathered millions of signatures. The controversy reached a scale rarely seen for a single drilling project, turning Willow into a national referendum on Arctic fossil fuel development. ConocoPhillips committed the money anyway, betting that even if the Trans-Alaska Pipeline is dying, it will live long enough to make Willow profitable. First oil is expected in late 2025, but no one has answered the question that matters most. Can 180,000 barrels per day save an 800-mile pipeline built 50 years ago for a world that no longer exists? Or is this the oil industry's most expensive attempt to resuscitate a corpse? Infrastructure built to solve yesterday's problem does not die suddenly. It decays over decades until the cost of keeping it alive exceeds the value it delivers, and then the decision makes itself. Energy transition experts who study aging fossil fuel systems describe this moment as inevitable, not catastrophic. Whether the Trans-Alaska Pipeline would fail was never in doubt. When it fails, and what replaces it, remain unanswered. Alaska's state government has not prepared for either. 90% of Alaska's operating budget comes from oil revenue. Prudhoe Bay production peaked in 1988 and has been falling ever since, dragging tax receipts down with it. Alaska's Permanent Fund, created in 1976 to save oil wealth for future generations, now holds over $80 billion, but the state burns through more than it deposits. Every year, the North Slope produces less. If the pipeline stops moving oil entirely, Alaska faces a fiscal collapse that no amount of federal aid or tourism revenue can offset. Infrastructure economists who model stranded asset scenarios say the same pattern is unfolding across the United States, just at different speeds. Refineries built for heavy crude that no longer flows. Coal plants designed for 60-year lifespans shuttered after 30. Pipelines laid when demand was rising, now carrying half their design capacity, while maintenance costs stay fixed. What is happening in Alaska is not an anomaly, a preview. Whether this is the endgame for American fossil fuel infrastructure is no longer the right question. The Alaska Pipeline proves the answer. Infrastructure does not die when we stop needing it. It dies when we stop being able to afford it. The oil is still there, 14 billion barrels, but the machine built to extract it is already gone. We just have not admitted it yet.